Hey everybody, today we're going to solve the predict the winner problem on LeetCode. So the problem description says we're given an array of scores, they're non-negative integers. Player 1 picks one of the numbers from either end of the array, followed by player 2, player 1, and so on. Each time a player picks a number, that number will not be available for the next player. This continues until all the scores have been chosen. The player with the maximum score wins. Given an array of scores, predict whether player 1 is the winner. You can assume each player plays to maximize his score. So here's the first example where player 1, the first player to go, cannot win. You would either choose 1 or 2. Either one you choose would leave your opponent with a 5, meaning they would end up with more points than you, so that output's false. This one right here is a little more complicated, but you can pick the 1 or the 7. Pick the 1, leaving him with a choice of a 5 or a 7. Whichever one he chooses leaves you with 233 more, so you end up with a higher score. Okay, so I've stopped writing the code for these during the videos because I think it's just a waste of time to watch me type, and I'm not that good at typing anyway, so I end up making a lot of errors and stuff. So we're just going to walk through the algorithm and how it works. So this is a minimax problem, and we'll talk about what that means here in a second. So here is the function that LeetCode initially sets you up with. They want you to return a Boolean saying whether or not the first player to go can win. So the first thing we do right after that, num's array is null, or there is just 1 or 0 elements in it, then we return true because we can always win. Just choose that first element. So this is actually totally unnecessary. Okay, so ignore that guy completely. We can go ahead and shuck him. Alright, so the first thing we want to do is we run through the array and we get the total sum from the first element through the last element. So the element of all the elements in the array. And right here we set up our memo, so we're going to memoize our recursive function to get it down to linear time. And right here we calculate our score. So my score, what I'm calling my score here, is the score that the first player to go will score. And let's talk about what that is, because that does all the work, okay? So what does my max score take in? So this is computing the maximum score that the first player, the player who's gonna go first in this game, can score. It takes in the integer array nums, the low index, which we start at 0, the high index, which we start at the end of the array, pointing at the last element, the sum in the range, which is the sum of the elements in nums between low and high, and then the memo, so we can remember all the answers we've computed. So if low is greater than high, we're just going to return 0. So 0 points for low being greater than high. There's no valid elements left. We check here, does our memo contain the answer? Basically, if it is not equal to 0, it means we've memoized it before, so we'll return that value, so we don't have to do any computation. So if we haven't seen it yet, so here's how we compute our score. So this is where the minimax comes in, and this is the key part of all of these problems. These are a few really common problems. The way it works is, okay, we're calculating the maximum score for the first player, and let's say that we're calculating our score first. Well, the only way we're going to know how many points we can score is if we know how many points our enemy scores, or the other player will score. Okay? So we calculate how many points the other player will score right here, and here's how we do it. We do it with 2 recursive calls. Okay? We say, okay, what happens if we take the first card, or we take the first number here? So that's what we do in this first call. We say, okay, we increment low plus 1 to indicate that we're taking the first number, and then the sum in range gets subtracted away nums of low because we've taken away that number. So that's the first score that our enemy can get. That's his maximum score if we take the first card. And then there's a second recursive call right here, which is his maximum score if we take the last card, the high card. Okay? And that will be the two scores that he can have, possibly, right? So when we make these two recursive calls, these are the two scores that our enemy can score in the game. And we obviously want to win, so we want to make sure he scores the least amount of points. So we minimize that, and we store that in minimum enemy score. Okay, I'll run that through one more time again. So basically, we just make two recursive calls to max score, where we take the first element, or we take the last element, and those are the two scores our enemy can score in the game. And we want him to score as few points as possible, because that will maximize our score. So we minimize that. We minimize those two calls, and we store that in min-enemy score. So at the end of these two recursive calls, we know the minimum score that our enemy will have in the game. Okay? So what will our score be in that point? Well, since we know that, that means that our score that we will score is going to be the sum of all the elements in the range, right? Minus the amount that the enemy scores. That will be our score. So that's how we compute our score. We compute our score by knowing the total sum of all the possible numbers in the range, and then we subtract away the amount that we are going to allow the enemy to score. And then we just memorize that and then return our score. Okay? And then up here, once we've calculated how much we're going to score in the game, well, how do we know if we've won? We've won if we have scored more than half the total points, right? Because there's only two players in this game. If we score more than half of the total points, then we've won. Now, there's one caveat to this problem. They say that a tie is also you winning. So we check here. We say, is the total number of points possible even? If it is, then we'll return the score that we had is greater than or equal to the total score by 2. If it's odd, then that means we can't tie. That means we have to score more than half. So we'll return my score greater than the sum by 2. So this is a min-max problem, and computing it is a little difficult when you start thinking about how you're going to take into account the fact that you have this other person who's going to play. But basically what you do is compute how much they will score, and then you figure out how much you will score based on how much they are going to score.